Okay then, here we are in the modulator stage. You'll see an aluminium chassis there with a heatsink on it. That's a solid state audio amplifier. Replaced a leak audio amplifier from the 1960s. Remember, these were built in 1963, so obviously designed about 1961, 1962. And Marconi's used a leak TL12 plus amplifier. 5 valves, EF86, ECC81, a pair of EL84s and a GZ34 to give 10 watts out into 2 100 ohm resistors on anti-phase, so you've got one phase one side and one phase for the other. We replaced the amplifier in the 1970s by, or 1980s actually, by a solid state one because it was getting hard to source all the tubes by then. So that's the solid state amp then that drives the first audio, which is here, which is a TT21, a GEC tube, much used by Marconi's. That's capacity coupled. You can see some rather large capacitors. That's capacity coupled into the next stage, which is a pair this side of 813s. And if you just look to the rear, there's another pair on the other side. This is a push-pull amplifier. So this valve is replicated on the other side. The two 813s are over the other side. The 813s serve as a voltage amplifier. We want to get here a swing of voltage, about 1,000 volts, peak to peak. That's what we want from this stage. We want to drive the output valves hard. So to get that, there's 1,000 volts of swing, but there is a slight complication when driving triodes. If you just look through, you can see the triode tube sat in the output there, exactly the same tube as used on the RF, BY1144L. However, to get the power out, we need to drive these valves in Class B. Class B normally involves grid current. But the poor old 813s can't deliver power. They can deliver voltage, but not power. So to get power, we need an intermediate stage. And here we have a pair, this side, of English electric valves, BY1654Fs. Satin boilers again. You can see the steam take off here, and you can see the water input from the base. So we've got the cathode followers here then that convert the 1,000 volt swing from the 813s into a low impedance feed for these two output tubes. These can convert that feed to low impedance because we want to drive these things with power, or we want to drive them into grid current. There's a better view here on the modulator of the tube setup because it's more open. You can see the grid here attached by this ring. That's the actual grid connection. Best put it on. The filaments or the heaters are here on one side. That's one side of the connections, and here's the other. And there's air blast cooling from above to keep these connections cool. We've got the boiler again bolted down, and we've got this strange piece of fishing line here. This is called a heat fuse, and it's on the tube there, and it's solder that should the tube overheat, the solder will melt, and the spring here will pull that off, and the switch will shut, and that will turn off the high voltage on the transmitter. So it's a protection circuit against the water flow failing. This assembly here is a collection of capacitors and resistors, a ladder of them, a feedback ladder, and from one end of it is connected to the valve anode, the other end is connected to earth, but we just take a little fraction of the voltage from the far end and send it back to the front of the transmitter as negative feedback. And we run about 15 dBs negative feedback. 21 is possible, or 0. It's switchable at the front. So that's the negative feedback. You've got various suppression components in here, just like on the RF, except they're designed for audio. So that's the modulator.